Hello and welcome. Today we'll be talking about some applications of quadratic equations. In order to do this, I've chosen a word problem, and in it I've included a variety of questions that require the use of all the skills that you have acquired in the unit of quadratic relations. So let's get started. The height of a ball from the ground can be described by the equation h equals negative 4.9t squared plus 60t plus 3. By reading the equation, I understand that I have a relationship between the time and the height, where time is the independent variable and height is a dependent variable. So the first question is asking from what height was the ball thrown. So at this point, I'm going to rewrite the equation, and I always encourage my students to write the equation, because once you write something, you kind of look at it more closely and you develop a better understanding about it. So plus 60t plus 3, and then I reread the question one more time. So the question is asking from what height, so we are trying to find the height. Seems that height is our unknown here, was the ball thrown. And I'm thinking, in this equation I have a relationship between height and time. So if I am asked to find the height, then I must need to know what the time is. But I don't see the time in here. So I start thinking, is the time given somewhere in here, but kind of as a hidden information? Remember that at the moment when you throw the ball, the time is 0. So in a way, we are given the time in here, 0 seconds. And we're going to say that in order to find the height, we simply have to substitute time by 0. So negative 4.9 times 0 squared plus 60 times 0 plus 3 will give the height of 3 meters. Now, therefore, we're going to say the ball was thrown from 3 meters height. Thrown from a height of 3 meters. Okay, so the next thing that we need to find out is the times when the height of the ball was 150 meters. It seems that this time we are asked to find the time, and I'm going to rewrite the equation again. H equals negative 4.9t squared plus 60t plus 3. So since I'm asked to find the time, and time appears in two different terms in here, I will need to know what the other variable is, the height. And this time I can clearly see that the value of h, or the height, is given 150 meters. So I can substitute height by 150 and see what my equation looks like after it. Do not, whenever we solve word problems, we kind of try to rush into thinking, okay, what will the answer be? What is it going to look like? When I solve word problems, I try not to stress myself out, but I think, what is the next step that I can take? Whenever you solve any problem, do not think of the last step, what would it be, and what the future at the end is going to look like. Always think one step ahead, because that's the way it works. So here we're going to solve the problem that what we see in here now, so I can see more clearly what I have and what I'm working with. So it's an equation. It's a quadratic equation, and because I see that one of the coefficients is a decimal, I know that the only way to go to solve for the unknown t is by using the quadratic formula. If I use the quadratic formula, it means that all the terms must go to one side of the equation, so I'm going to throw them to the left side. And here we go, 4.9t squared, that will become positive because it was negative, and it has changed sides. And then plus 60t, it becomes negative because it goes from the right to the left. We already have 150 in the left side. It will stay here, but 3 will join. 3 becomes negative 3, so that's plus 147 equals 0. So I have an equation with coefficients A 4.9, B negative 60, and C 147. And I have to solve by using the quadratic formula. Just to refresh your memory, the quadratic formula, as we have learned it, is x equals, and then we go big fraction, negative b plus or minus square root of b squared minus 4ac over 2a. And very often I see that people jump into finding x right away, no matter what kind of equation they're solving, and they write x equals. Remember that x is an independent variable, and our independent variable this time is not called x, it's called t. So therefore, you must be writing here t equals. And here we go, t equals negative b. I'm going to rewrite the formula, the quadratic formula, why not? And over 2a. Now I can substitute, and I can see my numbers more clearly. So we have t equals big fraction, and then we have negative b. Our b value is negative 60, so negative 60 plus or minus square root negative 60 squared minus 4 times a, which is 4.9, times c, which is 147, and that will be divided by 2 times 4.9. So I'm going to use the calculator to find what the expression inside the radical is. So I write down here t equals 60 plus or minus, and we got 60 squared in here, minus 4 times 4.9 times 147, which equals 718.8, and that is square rooted, and then divided by 9.8, which is 2 times 4.9, right? So now we have to find the values of t. So there is two possible values, so we're going to say t1 is 60 plus the root of 718.8 divided by 9.8, and t2, which is 60 minus the root of 718.8 divided by 9.8. So we're going to calculate them separately. So we got 60 plus the square root of that divided by 9.8. That's 8.85. So I'm going to round to 8.9 seconds. And 60 minus the square root of 718.8 divided by 9.8, that is 3.4 seconds. Okay, so what happened in here was that it seems like the ball has been at the height of 150 meters at two different moments, 3.4 seconds after it was hit and at 8.9 seconds after it was hit. So we're going to write the final statement here, and we're going to say, therefore, the ball has reached 150 meter height at 3.4 seconds and at 8.9 seconds gosh after it was thrown. Okay, so that would be the answer. We're done. Moving on. Now the question becomes, for how long was the ball above 150 meters? And I would prefer that I explain it to you a little bit more like visually. And it seems that here we have a ball that was thrown from the height of 3 meters. That was question A, right? That's what we found out. And it seems that the ball has reached 150 meter height. Remember, this is not to scale. I'm exaggerating it because I don't have enough room. Sorry. And the graph would look like this, right here. Okay, so it's a parabolic shape that opens down. So suppose this is 3.4 seconds, and this is 8.9 seconds, right here. Let me make this a little bit more realistic here. So 150 meters right here, and okay. So that would be 8.9 right there. Okay, so it seems that the ball was up in the air above 150 meter height from this part to this part, for this part of the trajectory. Now for this part of the trajectory, the time elapsed is between 3.4 and 8.9 seconds. So the time then must be equal to 8.9 minus 3.4. So that's about 5.5 seconds. So we are going to say that the ball was above 150. That's above 150, right? From moment of 3.4 seconds after it was thrown, right, at 3.4 to 8.9. So the time elapsed in between these two times is the difference, so 5.5. So we're going to say, therefore, the ball was above 150 meters for 5.5 seconds. So that's the length of time, right? Just to clarify. So let's move on to the next question. We're asked to find what is the maximum height of the ball. Now, we just discussed that this is a parabola that opens down, and the maximum height is marked by the vertex of the parabola, right? So to find the maximum height means that we need to know what the vertex is. And when we look at our equation, that's not in vertex form. We can't tell right away where the vertex is. So we have to convert the equation into the vertex form. So the equation is h equals negative 4.9 t squared plus 60t plus 3. So in order to convert to vertex form, we're going through the process of completing the square. You know, it's a little long, but I think it's essential that we go over the steps, and it will reinforce your understanding of it as well. So remember the first step, which was the fun step. You group the first terms, the ones that have the variables. Then we have to factor the coefficient that is before t squared. So this guy here has to come out. So let's take it out. Negative 4.9 is out. Then in brackets we'll have t squared, and then plus 60 divided by negative 4.9. So that would be 12.24. So I'm going to call this 12.2. And then we have plus 3 at the end. So now we need to complete the square. So we need to complete this expression. We'll pretend this is part of the perfect square. Well, it will become a perfect square very soon. And then we have the negative 4.9 still sitting there. And then in brackets, we need to add a term that will make this a perfect square. Now remember how we found the term that was missing that made the expression a perfect square? We always looked at the coefficient of t, divide by 2 and square it. Always. Take this, divide by 2, square it. So that's what I'm going to do here on the side. So 12.2, I will divide it by 2, and then I will square it. So 12.2 divided by 2, that's 6.1, and 6.1 to the power of 2 is 37.21. So I will add and subtract the same number. So first I have to write 12.2 t squared plus 12.2t, and then plus 37.21 minus 37.21, close the brackets, plus 3. So now we have our perfect square complete inside the brackets. Okay, and we have one last term here that we had to subtract just because we can't change the value of the equation, but this term has to come out. So we're going to take care of it now, this step. We're going to say we have negative 4.9 still sitting here. In brackets, we'll keep the perfect square trinomial, which is t squared plus 12.2t plus 37.21. And outside the brackets, we're going to take negative 37.21. Okay, so that's exactly what we had inside the brackets. And one thing that we shouldn't forget is this. Before the brackets, okay, 37.21 was inside the pink brackets, and before the brackets we had negative 4.9. Negative 4.9 is a coefficient for all of these terms. So if we decide to take this outside the brackets, we need to multiply by negative 4.9. So we will. So negative 4.9, and then we have plus 3, which was already there. So this is getting very close now to the end. So we have negative 4.9. Now in brackets, we have this perfect square trinomial. Guess what? We're going to make this, or write this in factored form. And we know how to do the factor form of it. So t squared, square root of it, that's t. And the last term, or second term in the binomial, will be the square root of this number in here, which is 6.1. And in the middle here, we're going to put the sign of the middle term, which is plus in this case. It's minus in this case. I can't forgive myself for this, but I have no choice. But here is learning from a teacher's mistakes. You see how we took out the negative? And when you take out a negative, the sign of the next term here will change to opposite. This was negative, take it out, positive. That's a negative. But I caught my mistake only because I know that time cannot be negative here. So we'll make a small change. Okay, I made this mistake, but you shouldn't. Alrighty then. It's too late for me to pretend that I did that on purpose. So here we go. We have t minus 6.1 squared. Everything else is perfect. Don't worry. Still have some faith. So we have to combine all these terms now. First multiply these two negatives, and then you add the 3. So negative 37.21 times negative 4.9 plus 3, 185 plus 85.329. Okay, quite an interesting number. So we're going to say that we're done, and we can see what the vertex is now. And the vertex is marked by the numbers 6.1 and 185.39. So I'm going to write this down, and we're going to say vertex. Let me make it green actually. Is at 6.1, and I'm going to round 185.329 to 185.3. Now let's think about what these numbers represent. Normally in an equation with x and y, this will be x and this will be y. But because we don't have x and y here, but we have t and h, this will be t, this would be h. So this will represent the time and the height at the highest point of the parabola, with a height of 185.3 and time being 6.1. So we're going to say that the maximum height is 185.3 meters. Okay, and I'm going to bubble this in a nice, cute looking cloud. All right, we don't have a lot to go. We'll see. This is quite an interesting problem. So I chose all these questions on purpose. You won't get any questions outside the ones that we're doing. So how many seconds after the ball was kicked did it take for the ball to reach the maximum height? So the maximum height happened at 185.3 meters, and it happened at the time of 6.1 seconds. So we're going to say it took 6.1 seconds. The last question is asking how long was the ball in the air? Okay, so again, I'm going to quickly draw the shape of our parabola. And we're going to say that it was thrown from a certain height, it reached the maximum and bam, down. And I'm going to add some details in here. Why not? Just so that we understand what's going on a little better. This is the maximum height. The maximum height was 185.3. And it happened when 6.1 seconds had passed. This is time. Now, the ball was up in the air from the moment it was kicked to what moment? To the moment that it hit the ground. So, what we do know actually about the ball when it hits the ground, which is this point right here, is that the height will be 0 at that moment. So the equation, which is negative 4.9 t squared plus 60t plus 3, you see this one here is 3 seconds, right? I mean, this is 3 meters from the moment it was thrown. So then we have to make the height equal to 0 to know how, or after how many seconds the ball would reach right here. Okay, so here we go. So we're going to solve for t. So no 9, negative b, negative positive 60, plus or minus square root 60 squared minus 4 times negative 4.9 times 3, and that divided by 2 times negative 4.9. So negative 60 plus or minus, and here we go again, square root of 60 squared minus 4 times negative 4.9 times 3. So that's 3,658.8 divided by negative 9.8. Let me make this prettier. Let's see. It's okay. Just want to make it a bit shorter. And we're going to find the time. It seems that we are able to find two values of time. Negative 60 plus root of 365, 8.8 over negative 9.8, and T2 of negative 60 minus the root of negative 3,658.8 over negative 9.8. Okay, so let's use a calculator. Again, I want to show you something. Actually, I meant to mention it before. If you want to calculate this number in one step, please don't forget to place brackets around, okay? Because it's very important for the calculator to use bad math. If you forget the brackets, then the calculator will recognize only these two numbers as dividing each other, not the whole numerator. So here we go again. Negative 60 plus the root of 36.8 divided by negative 9.8. So that's negative 0.05 actually. So 0.05 seconds. And the second one would be negative 60 minus the square root of 3658.8 divided by negative 9.8. That's 12.3 seconds. Now, we all know we cannot accept when the answers when time is negative. So we are going to decline that answer for sure. Why not? And we will accept this one for sure. But now we want to understand what they mean though. So why did we get negative time? Remember that in our case in here, we had the bow thrown from a certain height. Okay, so the reason why we get that negative 0.05 is because if the parabola was to be presented here with all its symmetry, then this would be the 0.05 time, this little fraction of time right here in the negatives, okay? And that's where we get it from. And 12.3 seconds will be the time right here. All right? And we are going to say that the ball was up in the air for 12.3 seconds. Okay? And that's about it. So I hope that this all made sense, and I hope that you got the most out of this lesson. And